Hello everyone, welcome to Learn Overflow. In this video, we will discuss another LeetCode problem that is non-decreasing array. But before that, make sure to subscribe this channel if you haven't already and also hit the like button. We are given an array of nums, that's the array of nums we have over here with n integers, so it has a length of n, okay? So your task is to check if it could become a non-decreasing by modifying at most one element. So we can do a modification of a maximum one elements to make it non-decreasing. So non-decreasing is basically means like increasing array, like it is a continuously increasing array, okay? Like all the values are in increasing order or like ascending order. So that's what we need to see, like if whether we can find, like we can do this or not, okay, by like we can modify at most one element. All right, so it says we define an array of non-increasing if n of I less than equals n of I plus 1. So that means it moves something like this and holds for every I that is 0 best and for I less than like 0 to n minus 2. So that's the way they define it, like it should be moving up always. Okay, for each node, it should be moving up always. So in the first instance, it seems like a pretty easy solution, right? That you come across this question, you run a loop through the whole question array and find out the number of instances where this condition doesn't hold, like nums I is greater than nums of I plus 1. So if this kind of condition holds in any of the places, particularly in our array, you will keep on counting those places, and then ultimately you will return the, like if the count is greater than 1, we will return false, right? So that's like the pretty much is the solution that comes in your mind. But remember, we need to see, like are there any kind of corner cases in this question, like are there anything that may happen in this question. So we'll look into that in details. Like yes, obviously the question is a medium level question, and obviously it cannot be such a simple that you will check whether the nums of I is greater than nums of I plus 1 or not, and thus you will figure out, okay, this is greater than equal, so we know like count number is this, so we cannot do that. So we need to check for that in details, okay? Let's say the examples are like 4, 2 and 3. It says true. It's more like if we just do something like there's a 4, okay, there's a 3 over here, say, and there's a 2 over here, okay. So it's like 4, 2 and 3. So we, if we need to modify anything, we can modify, like bring down 4 to 1, okay. Like if we modify this thing, bring down 4 to 1, then you can see that this is an increasing array, right? So like it's a non-decreasing array. So that's a easy kind of solution we find out. Also, if we find like 4, 2, 1, if the value is like something like 4, then it's something like 2, and then it's something like 1. Look here. This is the question where, like, this is the place where our like pretty much complexity comes in. What's that? We find that at this position, the value is going down. Okay, we found a counter being increasing, like the initial solution what we thought of, we use a counter and increase the counter, okay, and then we find that the value is again going down, and we find that the counter went to more than 1, and thus we return a false in the simple case, right? Let's try to understand some more examples in depth and see like what can be the conditions to just we need to look into, okay? So let me draw a graph over here so that I can make you understand better. Say we got a graph like this over here, okay? So in this graph, say we have like two values, that is A, and there's another value that is B, okay? So we find that at position I minus 1, our value was something like over here, okay? That's the value we had in I minus 1. And we find while coming to position I, so then our value went down to something like this, okay? Now, what can be the all the situations that may happen when it comes to the previous and the next position, okay? So it may happen that I minus 2 lies over here, over this range, okay? I minus 2 can lie in this range that is greater than A. I minus 2 can lie in the range of a like between a and b, or I minus 2 can lie in this range that is less than a but greater than 0, or simply less than b rather. Okay, so I managed to may lie in this tree range, and similar goes for I plus 1. That also can lie in this tree range. Like obviously it can be A and B as well, but that's not we are bothered. We are bothered because like nums of I equal to nums of I plus 1 is like increasing, right? But we are bothered rather whether it is non-decreasing or not. Okay, so equals value is not what we are counting because we have that over here. Okay, now let's understand further. Now, think of this two condition where this I minus 2 is something like over here, say over at this position, I minus 2 at this position, okay? Or like I minus 2 at this position, or we got another position, like another condition, I mean, like if we mark this as X, if we mark this as Y, and if we mark this as Z, and then it can be a thing like we find x a and b being like moving the points we have, or we find that there's a condition like a b and then it moves to something like z. Okay, so it may happen that I plus 1 ended up over here. So if we find a line like this, as you can see we find over this place, so if we find a line like this, we are pretty much sure that we don't need to do anything and this will end up returning a false. So that's the condition we can find over here. Okay, now let's try to see what condition we have over here. Like let's try to understand what other conditions can happen over here. Okay, the other conditions, like it may happen that the I minus 2 is at z. Okay, I minus 2 is at z, and it went up to something like yeah, like a, and it become b, and then it ended up somewhere between y. So what I mean is, say z a b and then y. Okay, so if it's going something like this, z a b and y, then we know we can bring down this to somewhere this position between z and b, and thus with a single change we can actually make it a non-decreasing, that is an increasing array, like non-decreasing array. Okay, so that's a one change, and that's the way we can change the following. Okay, also in the other case, if we say if we have a value like something like we have, it starts with y and then it goes ahead with a, then it goes ahead with b, and then it goes to something like say x, it moves up to x. I'll just draw this in a graph. So if it does something like this, then see what happens exactly. If we are at x, like y, then a, then b, and then it moves up to something like x, right? So if that's the graph we have over here, then we know that we can move this thing up to like between this place a and x, and ended up being like an increasing array for us. Okay, so that's what we can find. And there can be another condition. Okay, what can be that condition? Say we are left with an array, and that array is like, yeah, and that array is like, we start with z. Okay, we start with z, we went up to a, we went down to b, and then we again went up to say x. Now tell me, what will you do? This is an increasing, like if it's not it's like non-decreasing. If you find the moving average is like increasing anyways, right? So in that case you can move either this one, like not this far, you can move either this one to somewhere between this, or you can move this one to somewhere between this, right? So you need to make some changes over here. Like exactly what I mean is, like if we have z, a, b, and then x, and we can move either a down or b up, so to achieve the like increasing values. Okay, so we can see that in this kind of scenarios, like if we need to do something like this, then we need like one modification at a place. Like we can either do one modification at a place. Okay, and there is another, like you need to check which one to do that. So that's a bit confusing over here. Okay, you either need to move this down or this to move this up. Okay, so that's a confusion, and then that we need to decide over here, like which one will you consider, like one decreasing. But look here, is actually increasing in the long run. It's actually increasing in the long run. So which one you need to like change over here is like something you need to look for, right? There can be another condition. See here, if we start with something like x, not x, if we start, sorry, what I did, yeah, if we start with something like y, and then went up to a, then went up to b, and then went up to x. Okay, not x, rather, if we end up being like not x, if we end up being at uh, uh, y itself. Okay, so we just increased, we decreased, and we ended up at the same place. So in this condition, we are like we know like there are no possible way in which we can fix this array. Is it possible you can fix this particular array? Like, can you move this up over here? No, because that will be like if this position is below that. Can you move this down over here? No, if this position is going above our movement. So this is a kind of condition that we need to look for. See, we till now we figure out that how this can be done, like what are the changes we can see. But this is the kind of condition we need to look for. That is it like we cannot make changes, and like we cannot make like one change which is giving us a perfect answer over here. So it's like we know that even though there's only one initial incidence of decreasing value, like see, there's only one instance where the value is decreasing, but in no way we can actually fix this array. Like we cannot pull down this one or we cannot pull up this one, right? Because anyways, all are staying at the same place. And you know, we can be equal, it says like it can be equal over here. So don't forget about that. So that's the condition we need to keep in mind. So it's like we need to write a function that like over this function, what do we need to do? It will return false if the like number of errors we have, like numbers of decreasing errors we have, is greater than one. Okay, so in case the number of decreasing errors is greater than one, then obviously it's a false. So we don't need to look for it, right? And like that was the exact condition we have over here. But also, if we some conditions like this, y, a, b, and y. Okay, if we see something like this, then also we need to like trigger a false for that. We cannot go ahead with the true. And if we reach the end with like end of the num set without any of this condition, like this kind of condition or like continuous decreasing, then we know like, okay, we are good to go, and we could return a true over here, like as in this case. Okay, we can return a true. So that's the basic idea behind this. And since we are traversing our array only once, you can be pretty sure that if we're traversing only once, so it will be an order of n. Okay, an order of n solution. And so that's it about this expression. So let me just write some code. This will be a pretty small code, but pretty complex in the sense you need to remember what exactly you need to do. So exactly remember this chart, like the chart I showed throughout. This will help you to understand the code better, because while showing the chart, this code will not be there. All right, so we can say it's a pretty fast 1ms solution, and you can consider this 1ms or a 0ms solution as well. Like it's a pretty fast solution. Okay, so let's see what we did exactly over here. We did as what we said. Okay, so what exactly we tried to do over here is like we ran a loop. Like if you see, we ran a loop from I equal to 1 till num's length and I plus plus. And if you like, you can see like I took another variable that's modified equal to 0. So that's been counting like how many times we have modified our array, like how many times we have modified the array. That's the count we have over here. Okay, so that's the basic idea. Then we find like if a nums of I less than nums of I minus 1, that means there's a first decreasing is found. Then I found if like modified is greater than 1. So like if this num sub y is less than num sub y minus 1, that means we will we will increment this modified. Okay, and in the like modified will be 1 in the like after the first encounter of such decrement. And then if we find that it's like more than once, we are finding like once we found and then again we encounter like it's greater than 1. So if it's within the if statement, that means it again got some lesser than like decreasing values. So then we find that if modified is greater than 0, that means it has already been modified once previously. So that means we can straight away return, okay, return false. We don't need to look further. Like this is the condition. First we encounter this, and then we return like we change modified to be 1, and then we encounter 2 1, like again a decreasing, and we find that if modified greater than 0, obviously modified is greater than 0 because once we got incremented modified, and we straight away say return false. So we are not interested to move ahead with that. Okay. In the other case, what I've shown you in the graph is like if like there are two conditions to check if I is less than nums dot length minus 1. So that means I should be anyways if we are checking for I plus 1, I minus 1. So it's like why I'm checking for nums dot length minus 1, because I'll be running till like less than nums dot length. And if we need to check I plus 1 value, so we need to make sure that this is less than I like nums dot length minus 1. That is, there is another value called I plus 1. It don't give us an index out of boundary. So we're just keeping a check like this, and I is greater than 1. That means we can go ahead to I minus 2 as well. Okay, the exact thing what we are showing in the graph. Okay, so that's the idea behind this. And like to just have this check so that it doesn't give us an index out of bound error. And then what we go ahead with something like we check like if nums of I minus 2 is greater than nums of I. Okay, so that was the condition we had. Like we are trying to get that y a b y type value. So we find if nums minus 2, that is like the y value, is greater than like this is greater than nums of I. So this we found that b was like, if you remember exactly, we found somehow like this. This was like the first test. Y was there, that A was somehow above, B was somewhere down, and again we ended up in the Y somewhere here. Okay, so we're finding that if this value is, if it's going down, okay, Y to B, and nums of I plus 1 is that is I plus 1, we are looking at this value is less than nums of I minus 1. So we are finding that this value is also going down. Okay, so if this is something we find, if both of these are there, we return false. So that was the condition we look for y, a, b, y, right? So return false. And else, if after the whole array we have traversed and we couldn't find any of the other conditions being true, we return a true, that okay, we can modify only once and we can find out the exact thing we are trying to do. Our solution is good to go over there. So that's the idea behind the whole question. I hope I can make you understand how to solve this like a question like this. So thank you all for watching this video. Make sure you hit the subscribe button so that you can get daily notification on such videos or little questions like this. So thank you all. Hope to see you soon in my next video as well. Thank you.